All right, today we're going to look at using proofs with parallel lines, and then also looking at some other algebraic problems with what we call Crook problems. But to start, go ahead and try this warm-up and decide which lines, if any, are parallel. So in order to start this problem, you must start with what we know for a fact. We know for a fact that vertical angles are congruent. So we'll start with setting 8x minus 48 equal to 4x plus 24. When we solve that, we get x equals 18. So after we get x equals 18, we're going to plug x in everywhere. And we get the following for all of our angles. And what we notice with that then is that we have 96 and 96 here. And so because of that, we have these two angles are congruent, which means lines M and P are parallel. So M is parallel to P because of corresponding angles being congruent. So these two angles are both in the corresponding locations. They are both below that given line and then to the right. So then writing our proofs. So paragraph proofs, we're going to, write how we've done in the past. We're going to write down all the words and explain our logic here. So in the diagram, we are given the fact that M is parallel to P. So given the fact that M is parallel to, P is parallel to Q, then what are some different angles that we could say are congruent? So looking along these two lines, and then we have a transversal right here, I would be able to identify that 3 and 2 are congruent because they are alternate interior angles. So given that P is parallel to Q, then angle 2 is congruent to angle 3 because alternate interior angles are congruent. It's also given that angle 1 is supplementary to angle 2. And then given the fact that we have a congruent statement up here, we're going to take angle 3, because it's congruent to angle 2, and substitute it in for angle 2. So using substitution, angle 1 is supplementary to angle 3. And then the relationship between 1 and 3, if I look at lines R and S, they are in between these two lines, and they're on the same side of the transversal, and that would be the consecutive interior angles. So therefore, R is parallel to S because consecutive interior angles are supplementary. For the second one here, proof, we're going to look at these two lines being parallel and then also these two lines being parallel. There are many different ways to do this, but we need to think about ways to bring in angles 3 and 13 because those are the angles that it is asking us to prove. So given that M is parallel to N, bringing in a pair of angles along those blue lines, I'm going to say that 3 is congruent to 5. And that is because alternate interior angles are congruent. And then along the other two lines, the green lines, sticking with something that I have set, I'm going to go with 13, but then I'm going to double up here with 5. So given that A is parallel to B, then angles 5 and 13 are congruent, and their relationship is they are corresponding. Angles are congruent. Now, I have said 3 is congruent to 5 and 5 is congruent to 13, so I have repeated 5, all with congruent statements. So I can say 3 and 13 are congruent using the transitive property. Now there are a couple, you could have done different angles because there's 16 different angles here, but this is using these pairs of angles as one of the shortest ways to do this proof. One more proof here. This one we're going to do as a flowchart. Start off with our first given here. So given the fact that CE bisects angle DCB, that is going to tell me that angles 1 and 2 are congruent. And that is because when you bisect an angle, it implies two congruent angles. And then looking at my next given with CE being parallel, to AB, along this transversal there, I can say, so first off I need to say that CE is parallel to AB. Means angle 1 is congruent to angle A, and angle 1 and angle A are in corresponding locations, so parallel lines implies corresponding angles congruent. Also, with respect to those lines, but looking along the other transversal, I can say that angles 2 and B are congruent. And that is because when I have parallel lines, then alternate interior angles are congruent. And then now I can use the transitive property and connect because I have 2 and 2 and 1 and 1. So when I connect all of these statements together, I can say that angle A is congruent to angle B using the transitive property. So for the next one, we're using the parallel line postulate. And so this is saying that if I have these two parallel lines here, they would be parallel to a third line if they are when they're parallel to each other. So if I have another point right in here, I could draw a third line through that point, and then I could make all three of them parallel. I could draw that line in a way that makes all of them parallel. And so that's going to be helpful to me when I'm solving problems that are called Crook problems. So when I look at this one, I have that point right here, and if I'm given these top two lines are parallel, I'm going to draw a line through this point, and I'm going to make it parallel to all of them. So by making all of these lines parallel, I'm going to apply all of my parallel line properties. So using the middle line and the bottom line, I can say that this bottom part here of x and 40 are alternate interior angles. So I can say that this part is 40. Then using the same line and the top line, I can say that the top part here of x and 130 are consecutive interior angles, so they are supplementary. So this part is 50. So I have broken x up into two separate angles, the top part being 50, the bottom part being 40, which means that x equals 90. So again, we're trying to divide this angle up using this point in here to allow us to apply all of our parallel line properties. So draw a line through that point. It doesn't mean that it bisects. It could, but it doesn't mean that it has to bisect. So when I use this line, $150 and this top part are supplementary. So I know that this part is 30 degrees. Because the top part is 30, then I know that what's left for the bottom part must also be 30, because 60 minus 30 is 30. Then when I look at the bottom part here, so still looking at this line and then this line down here along this transversal, x and 130 are supplementary, so x must equal 150 degrees. Now on this point I have two separate points, so I'm going to have to draw, using these two lines are parallel, draw a line through 90, making it parallel, and draw a line through x and make it parallel. $25 and the bottom part there of x are alternate interior angles, so they are congruent in 25. I can't find anything else about x, so I'm going to go to another part of the problem. These two lines along that transversal, 130 and this top part here, which that angle was 90, those two are supplementary, so this leaves me with 50 degrees. The remaining, because the whole angle is 90, the remaining part must be 40. Then using alternate interior angles, I know that that is 40 degrees and that is 40 degrees, which means x is broken up into 40 and 25, so x must equal 65 degrees. So we're using those points to create another parallel line and allow us to apply all of our parallel line knowledge of dividing angles with alternate interior angles, corresponding angles, etc.